Hello students. Today we are going to do the main part of the next part, and that part is our Scilab. So you can see here that I've already opened the Scilab part where you can see in this case where I have seen the console. So this is your console, and on this side, whichever you have seen, that is nothing but your program files. And on this side, this is variable browser that is on the right hand side. And here you can see that entire part of the your programs, the values will get stored in terms of the Excels. And here you can see the command history. So whichever the commands I have given earlier, so those commands you can see it over here. So I can just copy paste on this side also. Now I will go for the next part, that is Euler's and the Runge-Kutta method and Euler's modified method. That was our program which we have to complete it as we have done it earlier, this part. So we'll see here that you have to just click it on the file. So you can see below this file there is one icon, and that icon is your SciPad. Okay, that icon is your SciPad. So this icon will get open. This icon will get open. We can see here this is called as Sci notes. Okay, this is called as Sci note. This is called a sign note. So you can see that I have to restore the sessions which I have already put it in my laptop. That is Euler's modified method. Modified Euler's is there. Runge-Kutta fourth order is there. 1/3 and 3/8 rule is also there. So we'll go for Euler's method. So I just say that the restore the sessions, last sessions. So after clicking it, we can find it out several here the programs which are lined up together. So you can see here, this is my Euler's program. Okay, what is our Euler's formula? Euler's formula is what? Yi plus 1 is equal to yi plus h times f of xi. So here every time I have to define this in terms of the function, correct? You have to find it out the function value of y. So what I've done is I've defined this as a function. You can see that this entire part is written as a function. Okay, entire part is written as a function. So now the first is, you can see here, whenever we are writing a function, in case of your Scilab, you can declare this function as function. So in C, what we do is we take it. So I just shared this because at a time he's sharing different one. Okay, so you can see that I just continue here that this is your function. So function name is given by the Euler, correct? And which values we have to calculate? We have to calculate x and y. So I've written in bracket, closed bracket, x comma y, that is equal to Euler. Euler is the name of the function. In open bracket, it is f comma x0 comma y0 comma h comma n and bracket complete. Now you can see here that I have to find out the function value of f. So we are declaring this name of the function as Euler, and the function will be defined on the console. X0, Y0 are the initial values. We have to provide the value of h, and we have to ask for the number of values. That is, you have to calculate 0.1 to 1 like that, or 0 to 1 by taking h is equal to zero point 0.1, all the values. So same thing we have done it here. Now you can see here that this is the first value. What is x1? X1 is x0, correct? And what is my y1? Y1 we are taking it as y0. So this is my initial value. And now we have to find out the next value. So I'm taking a for loop. So for the syntax is for I equal to 1 colon n. So what I have done is I have wisely stored it in x1 y1. you can keep that x0, y0, and you can take the values from 0 to n minus 1, correct? So here it is xi plus 1, that is the next value is what? Xi plus h, that is the earlier value plus you have to add h. And what is your yi plus 1? Yi plus 1 is the formula which we have seen, that is yi plus h times f of xi yi, correct? And you have to end the for loop and you have to end this function. Now what I'll do is I just take this, save and execute. You can see here. So you have to save this first, and how I have saved it, it is Eulers.sci, and then you have to execute this. Okay. So once I say that it is save and execute, you'll get the answer. Now this answer, what I have to do is I have to again share this. You can see here that this we have shared it here. Okay, this we have shared it here. So I just have to, so I'll share it again. You can see here that my console, Scilab console is over here. So now here we have executed the program. Here we have executed the program. And what I'll do is I just take the function. I'll define the function as, will define the function as, so this is say user friendly. So you can just copy paste here. Okay, so how you define any function here? So it is DEFF, that is defining a function. So dy by dx. So I'm taking this as y dot. Y dot is what? F of xy. And then you make a code. So here, what is name of the function? I'm taking here y dot. And y dot is what? Minus 2x minus y. So 2x, how you write it down? This is star. That is star is the product between the two values, and minus y, minus y. Now after defining this, what I have to do is I have to enter the value of x0. What is x0? X0 is 0, correct? And now you will enter the value of y0. Y0 is again 0, or I just take it as 1 instead of taking as 0. So you can see here x0 and y0 we have taken. Now we have to take the value of h. Now see, every time he is just giving me the value again and again. You can see immediately after this when I enter it, because I have not written there semicolon. So if I just add a semicolon, he will not display that value, okay, on the screen. So h is 0.1, h is 0.1 here, and after this we want the value of n to be 10. Okay, I want to display all these values. So n is equal to what? N is equal to 10. Why I'm providing all these values? Because our Euler function is what? It is written in the form of f x naught y naught. Then we require h as well as we require n. Now we'll call that function. Okay, this is called as function calling. This is called as function calling in the main term. So it is how you call it, x comma y. Okay, that is equal to, we want all the values. What is the name of the function? It was Euler, correct? And in bracket what we have done, we have taken f, then we have taken x0, then y0, then h, and then n, correct? X0, y0, h, and n. So this is in open bracket because we are calling that, and then you press the enter. You can see here in Scilab always the second values you get first. Okay, these are the values of x. So you can see here x we have started with 0 and ending at 1 with a difference of zero point 0.1. So it will take 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5 up to 1. And here it is when y is 1, 0, y is 1, and then he calculated with the help of that formula all the values till you get this up to 1. Okay, so this is our program. This is our program for Euler's method. Okay, so thank you. We'll see this next program in the next meeting.